Hey there everyone, welcome back to the channel. So recently I found a good problem based on trees, and this problem is 1600 rated on Codeforces. So we will be solving this problem, and the main agenda of solving this problem is to understand how DFS works and how we can traverse to check for each subtree for a given condition. So that is the main goal of solving this problem. So let's start by understanding the problem statement. After that we will move to the approach part. So this is given in a very weird manner. So I will try to explain the problem statement in a simple way. So what they're saying is we have been given a tree. For example, if I take the first test case, the tree is something like 1, 2, and 2, 3, 2 is connected to 3 and 3 is connected to 4. So this is a tree that has been given to us, and a color is associated with each node, and this is given in the form of the array, like here. First node is of color 1, second node is of color 2, third node is of color 1, and so on. So first node is of color 1, second node is of color 2, and these are all of the color 1. Now what they're asking here is we have to select any one vertex of this tree, and we have to make that particular vertex as the root of that tree. For example, if I select 2 as the root node, then how the tree will be formed? All the nodes will be hanged out around 2, that is 1 and 3 and 4. And also let's write the color of these all 1, 2, 1 and 1. Now they are asking that after making any vertex root, all the subtrees that are being generated here, that should contain similar color. For example, all the nodes in this particular subtree should be of the same color, and all the nodes in this subtree also should be of the same color. Okay, and in order to understand it in a more clear manner, let's have a bigger example. So for example, this is the tree. Okay, so what do you think, which node should I select for the root node? Obviously this node. Okay, because if I select this node as the root node, then what will happen is this will become a subtree of this node, this will also become a subtree, and this also become a subtree of the root node. Okay, and all the nodes in a subtree should have the same color. That's the only condition that needed to be satisfied. I hope the problem statement is clear to everyone. Now let's talk how we can solve this. The main thing that we have to notice here is we have to find any two nodes, consecutive nodes, which are of different color. Okay, and my claim here is either one of these two nodes is going to be my root node. Okay, and let me prove my claim. So I'm saying that my root node is neither this one, okay, nor this one. Now if the root, let's suppose the root is this. Now what will happen is in this subtree, these two nodes which are of different color will lie in a same subtree. Okay, and that is violating my condition that has been given to me. So in order to get the condition satisfied, we have to make either one of these as my root node, either red one or green one. Okay, you can also do one thing, you can also check for these two. Okay, because if I make these, let's suppose I'm making this as root node, then what will happen is these two will lie in a single subtree of this root node. Okay, and this is violating my condition. So my claim here is you have to find any two nodes which are of different color, and first of all you will make this one as your root node, and you will check for each subtree of this node that all the nodes in each subtree are of same color or not. Then you will make this one as root node and check for all the subtrees that all the nodes in all the subtrees are of same color or not. Okay, in this way you have to proceed, and you have to check only for these two nodes, or you can say these two nodes, any two nodes which are of different color, you can check for both of them. And if we are not getting a valid tree by making this as root node or this as root node, then our answer is going to be no. Beforehand you have to check one more condition, that if all the nodes are of same color, then you will just print any random node, like 1 to n, any random node, let's suppose 4, and you can return. Otherwise just do the DFS, and how the DFS will run, make 1 as root node. Let's suppose this is 1, I'm making 1 as root node, and DFS will go on, and at a time one node will be becoming the parent and one node will be becoming the child. And for each pair we have to check that are the color of parent and child are different or same. And if somewhere we found that the color of child and parent is not same, then we will just store our first node as this one, second node as this one, and just return from the DFS. Okay, and again we will do the next DFS from this node by making this as root node and checking for all the subtrees of this node, that all the subtrees are having same color nodes or not. And the same thing will be repeated for this node, and after that, at the end of the day, we will have our valid tree or not, and according to that we will print our answer, yes or no. So let me show you the code of this. I hope the concept part is clear to everyone. Okay, so this is the code for this. Let's start with the main function. I have taken n as input, and from 1 to n I have read the n minus 1 edges, because there are n node and n minus 1 edges in order to form the tree. After that, I have taken the color array as input. Then I have done the DFS from 1. Okay, I'm doing the DFS from 1. This is the parent and this is the child. Okay, now let's see the DFS function. And I'm maintaining two global variables where I'll be storing the first node and the second node, which are having the different color. Fine. Now what DFS is doing, that I'm sending two things, node and parent. Okay, and if the color of node is not equal to color of parent, then just store the node as the first node and parent the second node and return from the DFS. This is the simple thing that you will be able to understand if you have the basic understanding of DFS function. Okay, means recursion basically. And after that, I'm calling the DFS for I and becoming node is becoming parent for the next DFS call. This part is clear. After that, what I'm doing is here, if first node is equals to -2 and second node is equals to -2, means all the nodes are of same color. We haven't found any first node and we haven't found any second node, means all the nodes are of same color. Then in that condition, just print yes and any random node between 1 to n and return from there. After that, what I'm doing that is, till here I know that I am having two nodes having different colors, and I have to make one of them at a time as root node. So first of all, this is the function which is checking for all the subtrees that all the subtrees are of same color or not, and this is I'm doing for the first node. So let's check for subtree 1. This is the function, and in this what I'm doing is, this is the node. Okay, and when I call the DFS, means let's suppose this is the current node, let's suppose it is 4 is my root node, and I will call the DFS for children of 4. So these children should be of the same color as 4, isn't it? So I basically means the children of 4 here. Okay, so color of I should be equals to the color of node, means color of I, this color of I should be equals to the color of 4. And for the next time, DFS will be called for the children of this node. Now for the next DFS call, this will become node and these all will become I. So the color of I should be equals to the color of node. Okay, this is the condition that I'm checking. Fine. And this is the condition for checking that my root node should not be involved in this. For example, this is of the color 2 and this is of color 1 and this is of color 2. So you have to check for this subtree, not for the root node and its children. Okay, so for that condition I have written these two conditions. I hope it is clear to you. And the same thing I'm doing for the second node also. Before that, I'm maintaining the visited as false in order to do the DFS. Fine. And if my same is true, means all the subtrees are having similar color, then I'm just printing yes, otherwise I'm printing no. So I hope this problem taught you something, and this is a good problem for implementing the tree traversal, you can say. So I suggest and I highly encourage you to solve this problem by your own, and this will help you in improving your implementations based on the tree. Okay, so thank you for watching this video.